Hello everyone, welcome to a video on solving equations with variables on both sides. The goals of this video are to solve linear equations that have variables on both sides, identify special solutions of linear equations, translate words into equations and solve, use linear equations to solve real problems, and solve linear equations using a TI calculator. So if you have a TI calculator, make sure that you have it nearby. Just like in the video for solving multiple step equations, the goal in solving an equation is to get the variable by itself on one side of the equation. We want to isolate the variable and the number on the other side of the equation. We do this by performing the inverse of each operation on both sides of the equations. The steps to do this have not changed. So let's try example 1. Example 1, they're asking us to solve the equation 4x minus 6 is equal to 2x plus 10. Notice how this time we have x's on both sides of the equation. But we still have to follow the steps for solving equations. There is no distributive property, no grouping symbols anywhere, no fractions to take care of. In step 3, we're supposed to simplify the expression on each side of the equation by combining like terms. If I look at the left side, there are no like terms, and if I look at the right side, there are no like terms. Great, we're done with step 3 also. Now we need to do step 4. We need to collect the variables on one side of the equation and the constant terms on the other. Now, a long time ago, in a galaxy far, far away, I made the decision that I was going to place all my variables on the left side of the equation and the constants on the right side. So on this example, we'll put the x's on the left and the numbers on the right. But on the next example, we'll try it the other way around so that you see that that does not prevent us from getting the solution. So I have an x on the right side that is a positive 2x. If I wanted to get rid of the 2 only, I will see what the 2 is doing to x, and that will be multiplying. So the opposite of multiplication would be division. However, I don't want to separate the 2 from the x. I want to move the full term to the left side so that I can collect it with the 4x. Now, this 2x is positive, so I'm going to move it using subtraction. Again, I am moving the full term, the 2, together with the x. So that's why I'm allowed to subtract both sides by 2x. From left to right, that means that 4x minus 2x will be 2x. Bring down the minus 6. Don't lose the equal sign. On the right side, 2x minus 2x, that's going to be 0. We are subtracting, leaving us only with a positive 10. Okay? But we've only done half of step 4. We've moved all the x's to one side. Now we need to move the constants, those numbers that don't have any variables, to the other side, to the right side. In this case, I have the subtraction by 6. So the inverse of subtraction is going to be addition. So I'm going to add 6 to both sides. From left to right, we still have our 2x. 6 minus 6 will be 0, and 10 plus 6 will be 16. Now that we've done the second part of step 4, we are complete. We need to isolate the variable by multiplying or dividing. This time, I don't want to move the x. I want to remove this 2 that is multiplying x. So the opposite of multiplication will be division. So I'm going to divide both sides by 2. On the left, 2 divided by 2 is going to be 1, 1x or just x. And on the right side, 16 divided by 2 is 8. That means that we have completed step 5. All is left is for us to check the solution and make sure that the answer we got is correct. Let's check our answer. We're going to bring the equation. We're going to replace each x with our solution. Don't forget to bring the rest of the equation. 4 times 8 is 32. minus 6, that is 26. And on the right side, 2 times 8 is 16, plus 10 is also 26. So we end up with a true statement. Since this is a true statement, that means that 8 is in fact our solution. For the rest of the examples, checking if our solution is correct is going to be up to you. Okay, that wasn't that bad. Once we moved the variables to the left side, we ended up with an equation that was similar to the previous video on multiple step equations, and those we already know how to do. So tell you what, I'm going to ask you to pause the video. Try and see if you can either just start or maybe complete example 2 and then come back so that you can see if your answer matches what we get here. I'll see you in a little bit then. Pause the video and come back. All right, example 2. This time we do have parentheses, so we're going to distribute. Remember, parentheses is key. 4 times 2 is going to be 8. Bring the variable. 4 times 6 is going to be 24. Positive minus, that's a minus. Bring down the 9. Don't lose the equal sign. 3 times x, that is 3x. 3 times 7, 21. Positive minus is a minus. And don't forget the 8x. That wasn't that bad. Step 1 complete. There are no fractions. Step 2 complete. Combine like terms. We do have like terms to combine on each side. For example, on the left side, I can combine the minus 24 with the positive 9. And on the right side, I should be able to combine the 3x with the 8x. So that means that we have 8x, negative 24 plus 9 will be minus 15. 3x plus 8x, that's 11x. And then don't forget that minus 21. Step 3 is complete. Variables to one side, numbers to the other. Well, in example 1, I move the variable on the right side to the left side because that's my preference. But let's try it the other way around on this one. Let's move the variable on the left side to the right side, and you'll see that it's not going to stop us from getting the answer. Since I am moving the full term, I don't want to separate the 8 with the x. I'm moving the full term. This is a positive, so I'm going to move it with a minus. So minus 8x minus 8x. From left to right, 8x minus 8x, that's going to go to 0. Minus 15 is equal to 11x minus 8x is 3x minus 21. Now, because we move the variables to the right side, now we have to move the numbers or the constants to the left side. That means that this minus 21, we're going to move it with addition to the other side of the equal sign to collect it with a minus 15. Negative 15, positive 21. That is going to be positive 6. Bring down the 3x. 21 minus 21 will be 0. And we have completed step 4. The only thing left to do is multiply or divide. That means that now we want to detach this 3 from x. Since this 3 is multiplying x, the inverse or opposite of multiplication is division. So we are going to divide by 3. Whoa. I'm running out of space. I'm going to write it over here to give myself some space. So 6 divided by 3 is going to be 2. And on the right side, 3 divided by 3 now is 1x or just x. And this becomes our solution. Because we are finished with the steps, since this, checking if the solution is correct, is going to be left up to you. I recommend that you always come back and check that all the steps have been completed so that you know if this last statement is already your result. Not bad. almost painless. I'm going to ask you again. This is example 3. Pause the video, try it out, and come back to see if you get the same results. Let's start with the steps. There are no parentheses, but we do have fractions. I'm going to find the LCD. I think that we have already talked about the LCD in a previous video in which I stated that this is my preferred method and how to find the LCD, but if you know a different method, you are welcome to continue to use that method. So I start with the largest of the denominator. I go through its times tables. I think this should be enough. And then I take the smallest of the denominators and I start dividing that result. 4 divided by 2 is equal to 2. Since I was able to divide evenly my first result, that means that 4 is my LCD. Now you might be saying right now, but you can also divide 8 by 2 evenly and 12 by 2 evenly. Why not use 8 or 12? Well, LCD stands for the least common denominator, so we want the smallest of all of them. So if the first number can be divided evenly, then you can stop, because even if there are more numbers that can be divided evenly, we want the smallest of them all. Okay. Once we found the LCD to be 4, that means that each of these terms, this one is going to be multiplied by 4, and this 6 is also going to be multiplied by 4, and the term on the right side is also going to be multiplied by 4. I'm going to start from right to left, because I can see that this 4 and this 4 will get eliminated, leaving me only with 3p plus 5 on the right side. On the middle term, I just need to multiply 6 times 4, and that will be 24. Don't lose the plus. But right here, the 4 cannot be eliminated with a 2, but 4 can be divided by 2. 4 divided by 2 will be 2. That means that this 4 will turn into a 2, and this one will get eliminated. Now let me show you another method to see this. 4 is 2 times 2. So I can break this 4 into a 2 by 2, and one of these 2 will eliminate the denominator. So I still have a 2 in this 4p plus 3 on the inside. So then this 2 is going to multiply the 4p and the 3. So this is going to be 8p plus 6. All right, let's do a recap. We found the LCD to be 4. So we multiplied every single term by 4. On the right side, the 4 and 4 got eliminated, leaving us with 3p plus 5. The 6 times 4 turned into a 24. Don't lose the equal sign. And on this term, 4 cannot be canceled with a 2, but 4 divided by 2 is 2. So this 2 multiplied the 4p plus 3. That was a lot. Let's now go to 3 and combine like terms on each side. On the left side, I can add 6 plus 24, and on the right side of the equal sign, there are no like terms to combine. This is going a little crooked. Let's see if we can straighten it out. So this would be 8p plus 6 and 24 is 30 is equal to 3p plus 5. Let's move the variables to one side. I'm going to go back to what I know. I'm going to move this positive 3p all together. I don't want to separate the 3 from the p. So this is a positive 3p. I'm going to subtract it. I subtract because I'm bringing the 3 with the p. I'm bringing the full term. 8p minus 3p is 5p plus 30 is equal to, well, that is 0, just 5 alone. We still need to do the second part of step 4 to be fully complete. We need to move the numbers to the other side. Since I moved the p to the left, I'm going to move the 30 to the right. It's addition, so we're going to do subtraction. We're almost done. 5p on the left side minus 25 on the right side. I'm going to have to bring it over here because I run out of space again. Now the last step for me, because step 6 is yours, I need to either multiply or divide. In this case, 5 is multiplying p again, so we divide both sides by 5 to separate the 5 from the variable, or to isolate the variable. This is 1p or just p, and negative 25 divided by 5 is negative 5. Now these got a little complicated here. So if this example 3 gave you a little bit of problem, you might want to go to that handout. Remember the handout that says additional examples to see more examples with the step-by-step solution for something that has fractions so that you can truly master this example 3. Let's go to the next one. Okay, so this example 4, both A and B are special cases. So far right now, all the examples that we have done have had solutions, every single one of them. But sometimes equations have no solutions, or they have infinitely many solutions. For the no solution, it means that there is no number that I can plug in into the equation to make it true. And if it has infinitely many solutions, it means that it doesn't matter what number I put in there, the resulting statement is always going to be true. So let's try this one. Let's do parentheses. We have 2 of them, one on the left side and one on the right side. So this turns into 5m plus 27 plus 9m. Don't lose the equal sign. And on the right side, this is 14m minus 22. Okay, let's collect like terms. On the left side, I can add 5m with 9m. But on the right side, there are no like terms to collect. So 5 plus 9 will be 14m plus, don't lose the 27, equals 14m minus 22. So then I've done step 1, step 2, and step 3. Now I'm going to move the variables to one side. I'm going to move this positive 14m, so minus 14m. Let's collect it with a like term over here. Now 14m minus 14m, that goes to 0. So that gives me a 27 on the left side. The variables have been eliminated on the left side. Don't lose the equal sign. 14m minus 14m, that one also goes to 0. And I'm only left with a minus 22. My variables have been eliminated. I don't have anything to solve for. I don't have a way to find how much is m because there are no more m's. Not only that, 27 is not the same as minus 22. This is a false statement. So I have no variables left to solve for, and I get a false statement. That means that this equation has no solution. So if you try to check a solution, take any number that you want for m, any number in the world, plug it in, and you're going to see that none of those are going to give you a true statement. Let's try B. Check out what happens here. We do have a few parentheses. So this 6 times 2n is 12n, 6 times minus 1, negative 6, plus 3 equals 2n minus 8. 5 times 2, that's positive 10n, and 5 times 1 is just positive 5. Let's collect like terms on the left since there are no fractions to take care of. That's going to become 12n minus 3. Don't lose the equal sign. On the right side, I have 2 pairs of like terms. The 2n with a 10n and the negative 8 with a positive 5. So 2n plus 10n will be 12n, and negative 8 plus 5 will be minus 3. At this point, you can probably see what's going to happen. I'm going to move the 12n, the positive 12n, so minus 12n minus 12n. On the left side, the variables will get eliminated again, leaving us only with a minus 3. On the right side, the variables also get eliminated, but this time we get also a -3. So the left side equals the right side. There are no variables for us to continue with the steps to solve for, but this time we get a true statement. The left side equals the right side. What does that mean for us? Well, something pretty neat, and I want you to pause the video and check. If you decide to pick a number, any number, and plug it in the end, and check if it's a solution, it doesn't matter which number you select, a 1, a -1, 1,000, a -3/4, you're going to see that you're always going to get a true statement. For that reason, this 4b has infinitely many solutions. All the real numbers will work. So now you know that an equation can have either one solution, like all the examples we've done in the past, or you can have no solution, just like for A here, or infinitely many solutions, like in 4b. Just with example 3 and 4, that was a lot of information for one single video. But it's time to move on to, that's right, translating words into equations. This is the same table that we used in the solving multiple step equations. It hasn't changed. We're going to continue to use it to translate and solve. Because if you've seen the previous videos in the previous lessons to this one, we already have a lot of practice with translating and solving. So if you want to pause the video to translate these words into an equation and then we'll solve it together, or maybe you want to translate and solve and then come back, that would be awesome. Let's try it out. Example 5 reads, 3 times the greatest of two consecutive integers is 6 less than 6 times the lesser number. What are the integers? Let's take it one step at a time. To begin with, they are talking about 2 consecutive integers. We did those in the solving multiple step equations. So let's write them here. 2 consecutive integers. Let's say the first one is going to be x. Let me write it here. First one is going to be x, and the second one is x plus 1. It says 3 times the greater of the 2. Well, if this is x and this is x plus 1, this is the greater of the 2. So we will start with 3 times x plus 1. Moving on, it says is, so that's an equals, less than. Remember, less than means minus, but because we have the word than, we're going to switch these two. And then this one reads 6 times the lesser of the 2. So if this is a greater, this will be the lesser, the smaller one. So is equals, instead of 6 minus 6 times the lesser, it's going to be 6 times the lesser. Let's do that. 6 times the smaller of the 2 minus 6. All right, that wasn't as easy as the previous ones, but here we go. Let's get rid of the parentheses. Parentheses is king. This becomes 3x plus 3 is equal to, well, 6x minus 6. No like terms on either side. I'm going to move the 6x, the variable on the right side, to the left side. Remember, this is my preference. You can choose to move the variable on the left side to the right side and still get the same answer. So 3x minus 6x will be minus 3x plus 3 is equal to, this is 0, negative 6. Now I'm going to move the constants. Because I moved the variables to the left, I have to move this constant to the right by subtracting. Don't lose the variable. That's 0. Don't lose the equal sign. And on the right side, that will be negative 9. One last step, x is still not completely isolated. It's being multiplied by negative 3. So I'm going to divide by negative 3 both sides. So negative 3 divided by negative 3 will be 1x, or just x. And on the right side, negative 9 divided by negative 3 will be 3. Be careful. I'm just going to remind you that right here we are subtracting. So 6x minus 6x is 0, and positive 3 minus 3 is 0. But at this step, we are dividing. This is not 0. This is 1x, or just x. Now, are we done? Well, usually in the past, once we get to this point, we are okay, we are complete, but this is a word problem. We have to go check exactly what they want us to find. And in this example, they want the integers. They want both numbers. So if x is 3, how much is x plus 1? Help me out. Then that means that the integers are, well, the 3 that we got, and then 3 plus 1 will be 4. Are we done? I'm sorry to say no. We have 2 more examples, but that's okay, right? Because you like math, you enjoy math, you love math, and you cannot wait to do another one. So let's do another one. Let's read example 6. A boat travels upstream on the Mississippi River for 3.5 hours. The return trip only takes 2.5 hours because the boat travels 2 miles per hour faster going downstream due to the current. So how far does the boat travel upstream? This is a distance equals rate times time. They're talking about a boat going upstream and then downstream. So that's how we're going to create the table. Let's write the information. I know that upstream, I know the time is 3 hours. Sorry, 3.5 hours. I also know the time for the downstream trip, and that is 2.5 hours. Let's see what more information they're giving us. They're telling us that going downstream is going to be 2 miles per hour faster. So then downstream is going to be x plus 2. Since I don't know anything about the rate or the speed going upstream, I'm going to let that be x. So the distance here is going to be 3.5 times x, and this will be 2.5 times x plus 2. So our equation is going to be 3.5 times x will be 3.5x. And 2.5 times x plus 2, that's going to be 2.5x plus 5. I'm going to move the minus 2.5 to the left side. So 3.5x minus 2.5x, that's 1x, or just x. Oh, that worked out nicely. That's 0 is equal to 5. Now we need to be very careful here. We found x. Let's go back to the table. X represents the rate or how fast the boat is moving upstream. So this represents, let's see, miles per hour. So this 5 miles per hour is the rate or the speed of the boat upstream. However, that's not what they're asking. They want how far or the distance that the boat travels upstream. Let's look at the table. The table says that the distance for upstream is going to be 3.5 times x. Now you might be asking, did we need to solve this equation? Definitely. We would not be able to find the distance upstream if we don't know how much is x. In this case, x is 5. So this is 3.5 times 5. And if you multiply that, that's going to give you 17.5. So this 17.5 is the distance upstream, which is exactly what they're asking us to find. So then the answer will be the boat will travel 17.5 miles upstream. We're going to move now to something that I hope you like. Remember how I said at the beginning that if you have a TI calculator, to make sure that you have it near you? I'm going to show you how to solve these equations, not just the ones in this video, but also the video on simple equations and multiple step equations. And now this one where we have variables on both sides using a TI calculator. So let me bring my calculator. This is example 2 from this video. We already know what the answer is for example 2. Check your notes. An equation, remember, has a left side and a right side. If your equation is not using x's as the variables, go and change all those variables to x's. Rewrite your equation where all the variables are x's. Now we're going to go to y equals. Right here, here's y equals. In y1, we are going to enter the left side just the way it looks like. We're not going to change the thing. We're not going to distribute. We're going to do 4 parentheses 2. Here's the x up here where the alpha is. Minus 6. Be careful. There seems to be 2 minuses here, but they're not 2 minuses. This is a minus and this is a negative. Close it up. Plus 9. There, we've entered the left side of the equation in y1. You can either press enter or move down with the arrow, your choice. In y2, we're going to enter the right side of the equation. So that would be 3 parentheses x minus 7, close it up, plus 8x. Perfect. You might want to check here. Make sure that the left side and the right side are correct. Now we're going to go to graph. This graph. You want to make sure that you are able to see where the 2 lines meet. Let me come back here. The blue one is the left side of the equation. The red one for me is the right side of the equation. And I can see right here, more or less, is where they cross. You want to be able to see that. If you're not able to see that, you need to zoom out. Let me show you where that is. You go to zoom. Out is number 3, so you press 3 and then enter, and that is going to zoom your graph out. Let me show you. I'll come back to this one in a second so that you can see even more of the graph. You don't have to on this one, but if you're not able to see where they cross, then you're going to have to zoom out. Now we're going to do second, calculate, intersect, and enter. That seems like a lot. So we're going to do second right here in blue. We're going to calculate. You see how it's up here in blue? So press this key. This shows up. Go to intersect. Now you can either press the 5 or go down to the 5. It's up to you. Press enter. And now it's going to ask you this. Is this your first curve? They want you to check and make sure that you wrote the left side correctly. You say yes, so that's why I'm going to press enter once. Then they ask you, is this the second curve? They're asking you if you wrote the right side correctly. That's a yes, so we press enter twice. And then the calculator is asking, do you want me to guess? And you're like, yeah, dude, I want the answer. So you press enter a third time. And the answer will be this x value, not the y value, but the x value. According to this, the answer to example 2 should be 2. And if you go back to the notes in example 2, you'll see that that's the answer that we got. So now you know how to solve linear equations in the calculator. That's it. It's your turn. I'm going to leave these 3 for you to try them out. So you want to try them out on your own. Once you do that, try it out in the calculator and see if you're able to get that answer. Thank you so much for watching, and I'll see you in the next one.